June 1942. Somewhere beneath the Pacific, an American submarine captain lines up the perfect shot. His target, a Japanese cargo ship, sits fat and slow in his periscope crosshairs. He gives the order to fire. The torpedo streaks away, trailing its telltale wake of bubbles. The crew waits in tense silence. Then comes the sound that would haunt American submariners for nearly 2 years. A dull, metallic clang echoes through the water. The torpedo has struck the enemy hull and simply bounced off like a rubber mallet against steel. No explosion, no kill. The Japanese ship sails away, oblivious to how close it came to destruction. This was not an isolated incident. This was an epidemic. And what the United States Navy would eventually discover was one of the most catastrophic technological failures in American military history. A failure that crippled the submarine force during the most critical phase of the Pacific War. This is the story of the Mark 14 torpedo, the weapon that nearly broke the United States Navy, and then became the weapon that helped win the war against Japan. When the Japanese attacked Pearl Harbor on December 7, 1941, the United States submarine force was supposed to be America's silent spear. The plan was elegant in its simplicity. American submarines would slip through enemy waters, strangling Japanese supply lines, sinking merchant ships, and bleeding the island empire dry. Japan, after all, depended entirely on imported oil, rubber, iron ore, and food. Cut those lifelines, and the war machine would grind to a halt. The weapon chosen for this mission was the Mark 14 torpedo. On paper, it was a technological marvel. Designed at the Naval Torpedo Station in Newport, Rhode Island, beginning in 1931, the Mark 14 represented the cutting edge of American ordnance engineering. It was 20 feet 6 inches long and 21 inches in diameter. It weighed over 3,000 pounds. Its steam turbine propulsion system, powered by a mixture of alcohol, water, and compressed air, could drive the weapon at 46 knots for 4,500 yards. At a slower speed of 31 knots, it could reach targets 9,000 yards away. The warhead initially contained 503 pounds of trinitrotoluol, later upgraded to 643 pounds of Torpex, a devastating explosive compound developed by the British that was 50% more powerful than standard explosives. But the Mark 14's most impressive feature was supposed to be its Mark 6 exploder. This device contained both a magnetic influence mechanism and a contact detonator. The magnetic feature was designed to sense the steel hull of an enemy ship passing overhead and trigger the warhead directly beneath the keel. The theory was brilliant. A torpedo exploding underneath a ship would create a massive gas bubble and hydraulic shock that would break the vessel's back, causing catastrophic structural failure. One torpedo, one kill. No ship, no matter how heavily armored, could survive such an attack. The admirals at the Bureau of Ordnance loved it. There was just one fatal problem. The Mark 14 torpedo had never been properly tested with a live warhead. Not once. The reasons for this catastrophic oversight went back to the Great Depression. In 1931, when a new automobile cost $700, a single Mark 14 torpedo cost $10,000, the equivalent of roughly $200,000 today. The Navy's budget was strangled by economic hardship. The Bureau of Ordnance convinced itself that destroying expensive torpedoes in live fire testing was simply too costly. Instead, they tested with exercise heads filled with water, designed so torpedoes would float to the surface for recovery after their runs. The test procedures were designed to preserve the torpedoes, not to validate their combat effectiveness. In fact, between 1926 and 1941, only 2 live fire tests of the Mark 6 magnetic exploder were ever conducted. In one of those tests, the torpedo failed to explode. This should have raised serious concerns. Instead, it was dismissed. The culture of secrecy surrounding the Mark 6 exploder made matters worse. The device was classified so highly that its service manual was written but never printed, locked away in a safe where it did no one any good. Submarine crews went to war without understanding how their primary weapon actually worked. When war came, the consequences of this negligence emerged with devastating clarity. Within the first month of combat, reports began flooding in from submarine commanders. Something was terribly wrong with the torpedoes. Commander Tyrell Jacobs aboard the submarine Sargo was among the first to sound the alarm. Operating off the coast of French Indochina in late December 1941, Jacobs fired torpedo after torpedo at Japanese targets. 8 torpedoes at 2 different ships, not a single hit. When 2 more merchantmen appeared, Jacobs took extraordinary pains to get everything perfect. He pursued for 57 minutes, verifying every bearing, every calculation. He fired 2 torpedoes at each ship from 1,000 yards, practically point-blank range for a submarine. All 4 missed. Jacobs was a torpedo specialist. He knew the weapon better than almost anyone in the fleet. He became convinced the torpedoes themselves were defective. He deactivated the magnetic exploders on his own authority, a decision that could have ended his career. Even then, his hits did not improve. Exasperated, he broke radio silence, openly questioning the Mark 14's reliability to headquarters. The response from the Bureau of Ordnance was dismissive. They blamed the submarine commanders. Poor approaches, bad maintenance, crew error, anything but the torpedo itself. But the failures continued to mount. Throughout 1942, American submarines fired over 800 torpedoes in combat. By some estimates, 80% failed to perform as designed. Torpedoes ran too deep, passing harmlessly beneath their targets. They exploded prematurely, triggered by the hypersensitive magnetic exploder detecting the Earth's magnetic field rather than the enemy ship. They struck enemy hulls with audible clangs and simply failed to detonate. The Bureau of Ordnance refused to acknowledge any problem. They had designed the torpedo. They had tested the torpedo. The torpedo was perfect. The fault had to lie with the men firing it. The situation was made worse by the institutional structure of the Navy itself. The Bureau of Ordnance was enormously powerful, a semi-autonomous fiefdom within the naval bureaucracy. Not even Fleet Admiral Ernest King, who served as both Commander-in-Chief of the United States Fleet and Chief of Naval Operations, had direct authority over the Bureau. Challenging their judgment was career suicide, but one man decided the lives of his crews mattered more than his career. Rear Admiral Charles Lockwood arrived in the Southwest Pacific in June 1942 to take command of submarines in the region. After reading patrol report after patrol report documenting torpedo failures, Lockwood became convinced the weapons themselves were defective. When he asked the Bureau of Ordnance if they had recently tested the Mark 14, the answer was a curt no. Lockwood decided to conduct his own tests. Against explicit orders from the Bureau of Ordnance, he purchased a 500-foot fishing net and arranged for trials in King George Sound off Albany, Australia. On June 20, 1942, the submarine Skipjack fired a Mark 14 torpedo with an exercise head through the submerged net. The torpedo was set to run at a depth of 10 feet. When the net was recovered, the hole showed the torpedo had passed through at 25 feet. Additional tests confirmed torpedoes were running an average of 10 to 15 feet deeper than their set depth. Lockwood reported his findings to Washington. The Bureau of Ordnance dismissed the results, insisting no reliable conclusions could be drawn from the test. Lockwood repeated the tests with another submarine. 3 torpedoes, each set at 10 feet, cut the net at 21 feet. Finally, under pressure from Admiral Chester Nimitz himself, the Bureau conducted its own tests in August 1942. They confirmed what Lockwood already knew: the Mark 14 was running 11 feet deeper than set. The causes were embarrassingly simple. When the Bureau had increased the size of the warhead to make the weapon more powerful, they had failed to recalibrate the depth control mechanism. The heavier warhead changed the torpedo's balance, causing it to dive deeper than intended. Additionally, the hydrostatic depth sensor was mounted in a location that exposed it to hydrodynamic pressure during the torpedo's run, giving false readings that made the weapon think it was shallower than it actually was. With the depth problem acknowledged, submarine commanders began adjusting their settings to compensate. Hits increased. But sinkings did not. Ironically, fixing the depth problem exposed yet another flaw: the magnetic exploder was wildly unreliable. The Mark 6 magnetic influence mechanism had been designed and tested in the waters off Newport, Rhode Island. What the designers failed to account for was that the Earth's magnetic field varies dramatically by latitude and geography. A device calibrated for the North Atlantic behaved erratically in the equatorial Pacific. The magnetic exploder triggered prematurely, detonating torpedoes before they reached their targets. Submarine commanders watched in frustration as their weapons exploded harmlessly in the water, close enough to see but too far to cause damage. Between 8 and 10 April 1943, Lieutenant Commander John Scott in the submarine Tunney found himself in a submariner's dream scenario. Is less than number. Number is greater than. 3 Japanese aircraft carriers, Hio, Junyo, and Taiyo, were within range. From just 800 yards, Scott fired all 10 of his torpedo tubes. 7 explosions echoed through the deep. But when the smoke cleared, all 3 carriers sailed away virtually unscathed. Intelligence later confirmed every single explosion had been premature. The torpedoes had run true, but the magnetic exploders had triggered too early. In June 1943, Admiral Nimitz finally ordered the deactivation of the magnetic exploders on all Pacific Fleet submarines. The magnetic feature had promised so much. It delivered only frustration. But even with the magnetic exploders disabled, the nightmare was not over. July 24, 1943. Lieutenant Commander Dan Daspit in the submarine Tainosa was hunting Japanese shipping between Borneo and Truk. What he found was the prize of a lifetime. Tonen Maru No. 3, a 19,000-ton whale factory ship converted to an oil tanker, was steaming alone with no escort. At over 19,000 tons, it was one of the largest tankers in the Japanese fleet. Daspit set up his attack with textbook precision. He fired 4 torpedoes from 4,000 yards. 2 hit and exploded, bringing the massive tanker to a dead stop. Smoke billowed from the engine room. The ship began to list. With the target crippled and no escort in sight, Daspit moved in for the kill. He maneuvered to within 875 yards, a perfect 90-degree firing angle, the ideal attack position according to every submarine manual ever written. He would fire 1 torpedo at a time, watch for results, then fire again. The 643 pounds of torpex in each warhead should tear the tanker apart. At 9:30 in the morning, Tainosa fired her first torpedo. It ran straight and true. The white wake stretched across the water like a deadly finger. The crew waited for the crushing roar of detonation. Nothing. The torpedo struck the hull and failed to explode. Daspit fired again. Another hit. Another dud. He fired a 3rd time. A 4th. A 5th. Each torpedo struck the Japanese tanker. Each one failed to detonate. Some of the crew heard the sickening clang of steel on steel. 1 torpedo appeared to bounce off the hull and porpoise through the water before sinking. Over the next 2 hours, Daspit fired torpedo after torpedo at the crippled tanker. 15 to 16 torpedoes in total, multiple confirmed hits, 0 explosions. By 11:30, with a Japanese destroyer racing toward the scene, Daspit made a fateful decision. He would save 1 remaining torpedo and bring it back to Pearl Harbor as evidence. When Tainosa arrived at Pearl Harbor on August 4, Daspit stormed into the office of Admiral Lockwood, now commander of Submarines Pacific. Lockwood later wrote that he expected a torrent of curses damning him, the Bureau of Ordnance, the Newport Torpedo Station, and the base torpedo shop. He could not have blamed Daspit. 19,000-ton tankers do not grow on trees. Instead, Daspit was so furious, he was practically speechless. The torpedo Tainosa brought back was inspected at the submarine base. It was found to be in perfect working order, according to every specification. Lockwood knew now that the contact exploder itself was defective. He called in Commander Charles Mommsen, one of the most innovative submarine engineers in the Navy. Mommsen had developed the Mommsen lung, a portable breathing device that had saved countless submariners from sunken boats. He had overseen the rescue of survivors from the submarine Squalus in 1939. If anyone could solve the torpedo crisis, it was Swede Mommsen. Mommsen and Lieutenant Commander Art Taylor designed a series of tests. They fired live torpedoes at the underwater cliffs of Kahulau Island. They dropped warheads filled with sand from cranes at a height of 90 feet, calculated to replicate the impact velocity of a torpedo running at 46 knots. The results were damning. When warheads struck at the ideal 90-degree angle recommended by every submarine manual, 70% failed to detonate. The problem was discovered in the firing pin mechanism. The contact exploder used a firing pin that traveled perpendicular to the torpedo's direction of motion. When the torpedo struck its target dead-on, the force of impact generated enormous lateral stress on the firing pin. The pin would deform or jam in its guides before it could strike the percussion cap. The harder the hit, the more likely the failure. In a cruel irony, the more perfectly a submarine commander executed his attack, the more likely his torpedo was to fail. The fix was almost laughably simple. The firing pins needed to be lighter and stronger. Machinists at Pearl Harbor began modifying the exploders, machining away excess weight from the firing pins. According to Navy legend, some of the replacement pins were fabricated from aluminum propeller blades salvaged from downed Japanese aircraft, a fitting bit of irony. By late September 1943, submarines were departing Pearl Harbor with modified torpedoes. Within weeks, the results spoke for themselves. From late 1943 through the end of the war, the American submarine force became the most lethal naval weapon in the Pacific. Japanese shipping losses skyrocketed. In 1942, with the defective torpedoes, American submarines sank 134 merchant ships totaling roughly 580,000 tons. In 1943, with the fixes taking effect, the number rose to 284 ships, totaling over 1.3 million tons. In 1944, with the torpedo problems fully resolved and submarine numbers increasing, the slaughter reached its peak. 492 merchant ships, totaling nearly 2.4 million tons, were sent to the bottom. By August 1945, the Japanese merchant marine had been virtually annihilated. Less than a quarter of the shipping tonnage available at the start of the war remained afloat. Oil shipments from the Dutch East Indies had been strangled. Raw materials could not reach Japanese factories. Food could not reach Japanese cities. The island empire was being starved into submission. American submarines, comprising less than 2% of the United States Navy's total fleet, accounted for 55% of all Japanese shipping losses during the war. They sank over 1,300 merchant ships and approximately 200 warships, including the battleship Kongo, the only Japanese battleship destroyed by submarine action. The carrier Shinano, the largest vessel ever sunk by submarine, went down in November 1944. After the war, the Japanese cabinet reported to the National Diet that the greatest cause of defeat was the loss of shipping. The weapon that made this possible was the Mark 14 torpedo. The lessons of the Mark 14 scandal reshaped the United States Navy. Rigorous testing protocols were implemented across all weapons programs. The Bureau of Ordnance was forced to accept outside evaluation and oversight. Submarine commanders gained greater autonomy, and their operational feedback was taken seriously. The institutional arrogance that had cost so many lives and opportunities was, at least partially, corrected. The Mark 14 itself continued in service long after the war ended. Modifications incorporated wartime lessons and adapted the weapon for the Cold War era. The torpedo remained a valuable component of the American submarine arsenal until approximately 1980, nearly 40 years after its troubled combat debut. Today, the Mark 14 stands as a monument to both catastrophic failure and remarkable redemption. For 20 months, it crippled the American submarine force at the most critical juncture of the Pacific War. Commanders watched helplessly as their weapons failed against enemy ships they should have destroyed. Men died because bureaucrats refused to acknowledge flaws in their designs. Targets escaped because accountants deemed proper testing too expensive. But when the problems were finally confronted, when officers like Charles Lockwood and engineers like Swede Mommsen refused to accept excuses and demanded solutions, the Mark 14 became exactly what it was always supposed to be: a ship killer, a war winner, the weapon that starved an empire. In the end, the story of the Mark 14 torpedo is not merely a tale of technological failure, it is a story about the cost of institutional arrogance, the price of inadequate testing, and the courage required to challenge authority when lives hang in the balance. It is a reminder that no weapon, no matter how advanced on paper, matters if it does not work in combat. And it stands as proof that even the most disastrous failures can be redeemed when the right people refuse to give up.